Here we go. We have a question container with most water. So you have given an array of non-negative integers whose where each element ith element represents the height of the vertical line. We need to find the maximum amount of water. So here we don't need to find the total amount, we need to find the maximum amount that can be contained between any two lines together with the x-axis. In the case of single vertical line, it will not be able to hold water. So suppose we have we have array, and in this we have first height 1, then height 5, height 4 and height 3. So between this and this, how much water can we store? So the minimum height is 1, so we can store one height, and the width will be 1, 2, 3. So it will be height multiply width. So the answer is 3. And in this case we have this and this line. So the minimum height is 3. So and the height is 3 and the width is 2. So the answer is 6. So one answer. This is our maximum answer till now. Then between this and this line, the minimum height is 3. Why we need to take minimum height? Because if we fill more water, the water will overflow. So that's why we need to find the minimum height between any two pillars. So the minimum height is 3, and the difference means the width is only 1. So water stored between these lines is 3, and we have maximum amount of water as answer 3, as answer 6, and in this the answer is 12. You can calculate it, and in this we have 25. So let's build the approach. I have taken this test case, and we need to find the total amount of water. So in this question we're gonna apply two pointer, our L pointing to 0th index and our R pointing to the last index. Then how much water can we store between these two pillars? So what's the minimum height? Minimum height is this pillar. So between this and this pillar, height, so we have this height and we have this width. So it will be 1, height is 1, then width is 1, 2, 3, 4, 5, 6, 7, 8. So the amount of water stored between this pillar is height multiply width, which is 8. So as our L is smaller, so we will increment our L. Then L is here, R is here. So how much water can we store? The minimum height is 7, means the rth value, and what's the width? Width is 1, 2, 3, 4, 5, 6, 7. So the answer will be 7 multiply 7, which is 49. As our R is smaller, so we will decrement our rth value. How much water can we store? The water stored at this position is the minimum height. So this is our height and this is our width. So width will be 1, 2, 3, 4, 5, 6. So 6 multiply 3. This will be our one of the answer. Our R is smaller, so R will be here. What's the minimum height? So you can take any height. So let me take this height, and what's the width? So it will be 1, 2, 3, 4, 5. So the answer is 7 multiply 5. So this much water can be stored here. So 7 multiply 5. Then our R is here. So you can like update any of your pointer, either L or R. So I am incrementing my L. So how much water can be stored at this position? So it will be minimum height means Lth value, then width. So height is this and width is this. So it will be 1, 2, 3, 4. So 4 is the width and 6 is the height. And now let's jump to next index. As our L is smaller, so we have this. So height is 2, width is 1, 2, 3. So it will be 6. Then let's increment our L, because our Lth value is smaller. So how much water can we store at this position? So it will be, height is 5 and width is 2. So it will be 10. So our R is here, our L is here. As our L is smaller, so I have incremented my L. So we have this, and how much water can we store here? Minimum value is L, and width is 1. So it will be 4 is our height and width is 1. So 4 multiply 1 is 4. And that's it. I hope you got the idea. So now let's code this. We have n left and right pointer answer while this condition hold if our lth value is smaller. So take the maximum between already contains value or height multiply width and update your L. Then our RS value is smaller. So find the maximum between height and width and update your R and return the answer. That's it. The time complexity in this case is order of n and space complexity is constant, and we have solved this question in the expected time and space complexity. If you learned something new, give this video a thumbs up, subscribe to this channel, and thank you all for watching this video.